This is new. So let's talk about domain and range. So this is at the A level. Once again, very doable. This would normally be C level if we were in person. But domain and range is huge, huge, especially domain in advanced math classes. Pre-calculus, you will spend quite a bit of time working on domain and range. We will talk about it with all of our functions moving forward, but not something that I'm going to require at the C level, but it's just something that we really, just something to be thinking about. When we think about domain and range, these graphs are two-dimensional, right? They're going in the Y direction, X direction, and the Y direction at the same time. We can do three-dimensional graphs, which would make like a solid, where it can actually come out in 3 dimensions. And it's pretty cool with computer graphics, how well we can do those. But we could do three-dimensional graphs. We're used to two-dimensional graphs. When you're looking at domain and range, we're actually going to step back and we're going to think in 1 dimension at a time. Just what's going on with the X's, ignoring the Y's completely. And what's going on with the Y's, ignoring the X's completely. So the domain is all of the possible X values of this function. And the range is all of the possible Y values of this function. And we write it as an interval, just like we did in Unit 1 when we looked at inequalities. Okay, we write it as an inequality. Where do the X's live? Now, there's all kinds of different things that can happen. And I tend to think of this as, where does a function live? Where does it live? What values can it reach? So we have graphs, a lot of the things we graph, a lot of our functions are like this line right here, where it goes everywhere. It goes from -infinity to infinity in the X direction. Every X value is covered here, right? It's going to keep going all the way to -infinity, all the way to infinity, just keeps going and going. And at the same time, it's going from -infinity in the Y direction to positive infinity. So we have -infinity to infinity in the Y direction. So if we were to write what the domain is here, and that's my X's, we can say the X's are everything from -infinity to infinity. Now we have a shortcut way of saying that. And that means any number, 7.12347, any number I can think of is going to be on this graph. Any real number, square root of -1, the only imaginary number, is not there. So we don't always write -infinity to infinity. In class, I would be having us write this fancy little R that means all real numbers. However, it's hard to find on a keypad. It's really hard. And not even all equation editors contain it. So not going to expect you to use it in class because you're using the keyboard. So you can either write all real numbers, or you can even write out -infinity, less than X, less than infinity, all different ways. I'll accept this, whatever works for you. But all real numbers for our domain. And guess what? Our range is the same, -infinity, all the way to infinity. Notice it's a Y that goes in the middle here. I will mess this up. And some of you did on your daily quiz as well. I make this mistake all the time. I'm so used to putting an X there that I just automatically go there. But when you're dealing with the range, you're telling me about Y values. So it should be a Y that goes there, not an X. Or you could just use the symbol. The range is all real numbers. Okay. Okay, so that's what can happen. We could also, though, change colors, getting a little too blue here, have things where maybe it has one limitation. So in this case, a parabola, classic parabola, it does, these X values, we've talked about this. If I scroll out, even though it looks like they're going up, 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 if I could scroll out far enough, I would see that they are still going out a little bit forever and ever and ever and ever. So my X values will be -infinity to infinity. Okay? But the Y's are not. Parabolas have either a floor or a ceiling. So when I'm looking at where does this function live, notice it's never going to be down here, ever. We're never going to have a y value of -5. It doesn't dip that low. There's a minimum here. So it's got a floor, and I often will draw lines like this in order to help myself see where that floor is. Y's will never be less than -3, okay? So the domain is all real numbers, or -infinity to infinity. The range, however, is all y values greater than or equal to -3. It can't be -4, can't be -3.1, but it can be -2, -1, 1, because I'm thinking only up and down. So it goes all the way to infinity. That thing keeps going up and up and up, but it has a floor. So y is only those things greater than or equal to -3, okay? So that's the way we would write the range. The other thing to be careful of, a lot of times we see that and people think, oh, maybe it doesn't touch that point. It touches the vertex. So you've got to include that equal to. The vertex is there. And sometimes you just have to trust your graph. You don't see the equation. Maybe it's a little above, but you can assume if we make a parabola that it is touching the whole number. Questions on that? All right, that's a classic parabola. It can open up like a cup, or it could go down like a frown, and then it would have a maximum, and it would be all y values less than. The other thing that can happen is we can have a radical function. This is that square root function that we just were looking at. And notice with this one, the x values are limited. It has a wall on one side. So we've got things with just like a floor or one wall, one limitation. In this case, it has a wall on the x-axis. The smallest x possible is -4, okay? X will never be less than -4. It can't be -5. It can't, nothing is back here. So it's limited in where it is. It also has a ceiling, and all radical functions, square root functions will either have a floor or a ceiling depending on if A is positive or negative, just like with parabolas. So it's got this ceiling as well, and that's where y is -1. So in this case, we have two walls. So we would say the domain is x's greater than or equal to -4, and the range is the y's greater than or equal to -1. Any questions on that? Okay. So now let's look at the actual problem that was on the daily quiz, okay? 2 tips. Don't think in terms of coordinates, and this happens every year. People will try to tell me that it's all x's from 1, 3 is less than x, which is less than 5, 9, or whatever. And you're looking at it as the 2 x values. Let me mark attendance here. There we go. You're looking at points. You're just so used to thinking of these things as coordinates, and they are, but you're not going to want to use coordinates for your domain and range. That doesn't make sense. That would be thinking 2-dimensionally. And remember, we're only thinking 1 dimension at a time. So we don't want to do that. So instead, we're going to just focus on those walls. So I'm going to start with the x's. I notice here, there we go. I notice here that there's a wall. I notice it also has an open circle. Just like we did before, that open circle means it doesn't quite get there. And to show that, I like to use a dashed line. Now, these lines are not part of the graph. This is just how I see domain and range, and I find that it very much helps students see domain and range. If you just kind of, okay, there's that wall, and you can see that the the graph never gets back here. Okay, so I know for my domain, the smallest possible x value is 5, and it doesn't quite reach it. So it's going to be x is greater than 5. Well, what happens on the other side? We'll have a closed circle. So I'm going to use the solid wall to show that, okay, the largest x possible value is 11, and it can reach 11. So my x's are limited to this section right here. And a lot of times it's great to just focus on the axis because it's like a number line. And you can see, okay, it goes from 5 to 11. Okay? And it's an open circle here and a closed circle here, relating it back to what we learned in Unit 1. Questions on that? Watching the chat, listening. Okay, now we're going to look at the y-axis, the range. What is the range of this graph? Well, you want to focus, you're so used to focusing on endpoints. You're like, it's right here. But this is like a red herring. It's like, hey, look at me, but it's only there to distract you, okay? So when I look, the actual lowest y value, I just look for, it's like, I like to think of it as like, kind of like that rangefinder. They use it at the Blazer games or Price is Right, where they're like, and you'll be like, yeah, I think the price of the stove is in that range. It's kind of like what I'm doing here. I'm moving it up, haven't hit my graph. There it is. There's that lowest value. Notice it has nothing to do with that point. So I now know my y's are going to be greater than, and here's that point over here, and it touches the axis, 4, or equal to. Now I need to go to the top, okay? That's a solid point as well, so I'm going to use that solid wall all the way up to the greatest value of y, which is right here. It touches that too. It's 12. So the y's are greater than or equal to 4, but less than or equal to 12. It's between 4 and 12, including 4 and 12. Any questions on that?